Okay, so the warm-up's just asking to find the sine at these different angles. So the sine of 0, we can look at our unit circle here. The sine of 0 degrees is 0. Remember, we're looking at the y-coordinate for sine. 0. Then we're going to look at the sine of pi over 2. Y-coordinate here is 1. And remember, this is a graph, right? So, and the unit circle has a radius of 1, so any extreme point of this circle is 1. So at this point the radius is 1, so but it's all x value, right? So it's cosine, but and the y value is 0 because it's still right here on the x-axis. But here we're going up 1, right? And then our cosine would be 0 because we haven't gone over any. Because remember, right left is x or cosine, and up and down is y or sine. So in this case, our sine is 1, sine of pi, back down here to the height being 0 again. And then after that, the height's down here at -1. And then back up here to 0. 0, 1, 0, -1, 0. And then for cosine, well, let's see, we're starting over here. Remember, right to left is x, so furthest right is 1, the radius of the circle. Cosine x is 1 here. And then at here, we're going left, right? So then we're back at x equals 0. Then we go left more, and we're back at x equals -1. And then we go forward again to 0 right here, to x equals 0. And then we go forward again to here to x equals 1. So it's going to be 1, 0, -1, 0, 1. So what is the minimum value that y equals sine x could have? What's the maximum value? And what is about y equals cosine x? So for sine, the minimum sine value, remember, sine is representing the y value. So let's see if I can get this on screen. So we're looking for our lowest y value and our lowest x value. So remember, y just represents the height. So what is the tallest point of the unit circle? It's right here. And our y value here is 1, and the lowest point of the unit circle, it's right here. Y value is -1. So the minimum is -1. -1 is less than y, which is less than 1. Technically it's equal to, but I don't have that. So y is between -1 and 1. That the lower limit's -1, the upper limit's 1. And I should say sine. And then what about for cosine? Well, cosine, it's the same thing. We're going from the far left over here to -1, over all the way over here to 1. It's actually the same for cosine. Look at 5. The value that we plug into theta is what part of the unit circle. The value that we found for y is what part of the unit circle. So for theta, theta always represents an angle. So if we're looking at the unit circle, we're looking at the angle. You know, the angle here is 0. The angle here is 30 degrees. This is a 30-degree angle. This would be a 45-degree angle. This is a 60-degree angle. And then this is a 90-degree angle. And so on. So theta is always going to be an angle. You take the sine of an angle. The only thing you can plug into the sine, cosine, tangent functions are angles. So theta is the angle, and then y is, well, what's y? Y is sine theta, right? It's the sine of that angle. Sine of that angle, which is the y-coordinate. The y-coordinate at that angle on the unit circle. Right? So if I say 60 degrees, the y-coordinate at the 60 degrees is the sine, so root 3 over 2. Use your unit circle to find each of the following values. So negative pi over 2, remember negative angles, you just go backwards, but you're just counting the distance. So pi over 2 is this 90-degree angle here. And the sine value down here at the bottom is negative 1. We saw that already. It's the same as 3 pi over 2. And then negative pi, well, that's the same as pi, right? This is pi, but negative pi is just going that direction in the other way. And it only works at pi that way because it's halfway. So then negative 3 pi over 2, 1, 2, 3 pi over 2, which is equal to pi over 2. That's just 1. Oh, this one was 0. And then negative 2 pi, well, that's the same as 0, so, or 2 pi. So this is all of the values we've figured out so far. So now we're going to plot them. So we can just keep looking back over here if we need to. Negative 2 pi, the sign is 0, goes 0, 1, 0, negative 1. So let's do that. 0, 1, 0, negative 1. There we go. And then 0, 1, 0, negative 1, 0. 0, negative 1, 0. And connect the dots. So now we're going to put in some more values because I kind of showed you what the graph looks like here, but if you didn't see this, you may have thought that these were straight lines between them. They are not. They curve here, and that's very important, and we're going to see some other values in here that kind of make it do that. So remember, the sine of the pi over 4 is square root of 2 over 2. I'm just going to copy that because sine of 3 pi over 4 is also square root of 2 over 2, right? Square root of 2 over 2, square root of 2 over 2, and then this is negative root 2 over 2, negative root 2 over 2. I'm just going to copy paste to all these and put the negatives in front after. And so now this is the graph we did on the last page. And then these are the points we just added. See how we've got pi over 4 is about equal to 0.707. So we're going to use that when we plot these points. This one is equal to 0.7, so that should be right about here, which works. This one's 0.7, and then the next ones are negative 0.7, right? So that's going to be like right here, and that's pretty close. That looks about right because we're close to negative 1, but that's why it curves, because if we did a straight line between these points, it wouldn't hit these root 2 over 2 points. So it's a curvy path between the extreme points. So this GIF just shows a combination of the unit circle and the y equals sine x graphs. We kind of see how it works. Notice that the line going across, it's only looking at the height on the unit circle, because when we're looking at sine, we're looking at the y value. So we don't care where the arrow is side to side, we're only looking at the height of that dot. And that's what we're plotting. And at each point, at each angle, we're plotting what the height is at that angle, and it makes this graph. So now what are the domain and range? We could look back at the graph. We could also look back at that very first slide. The range, remember we said, or slide 3 I should say, remember we said that the minimum value for sine is negative 1 and the maximum value is 1. So if we look back here, well, remember we said y is our sine value. So this is going to be negative 1 to 1. And then our input on this graph, this should be theta, but our input is the angle theta, right? Well, what's the lowest angle I can put in there? Is it negative 2 pi? That's the lowest one I graphed. But we know about coterminal angles, and we know, if I know that if I gave you negative 4 pi, you'd be able to graph that the same as you'd be able to graph negative 2 pi. In fact, they're coterminal angles, so they'd be the same. And you can do it with negative 6 pi and negative 8 pi and so on until negative infinity, and up until positive infinity. So now we're going to just look at this in degrees and see if it changes much. Negative 2 pi is the same as negative 360 degrees. Negative 3 pi over 2 is negative 270 degrees. Negative pi is negative 180 degrees. Negative pi over 2 is negative 90 degrees. Zero radians is 0 degrees. Pi over 2 is 90 degrees. Pi is 180 degrees. 3 pi over 2 is 270 degrees, and 2 pi is 360 degrees. So now we're going to plot our points from the last graph. Hint being that it's very similar to slide 8. Well, we know at negative 360 it's at 0, right? And I'm just going to go ahead and assume it's bouncing between 1, 0, and negative 1, because that's what all our points were. And there it goes. So the nice thing here is that it's just going to repeat like this forever. And with degrees, it's actually the same graph. We're just changing our x-axis. Right? So, but even when we do the domain for x, we've changed it into degrees, but it doesn't really matter much because the lower limit's negative infinity and the upper limit's positive infinity. And then this is still negative 1 to 1 because they have the same outputs, their signs. And that's that. Got them all right.